Jeff.
Yeah, and who's Jeff? Who's Jeff? All right. So, up until literally late last fall, I was a consultant for many years, and one of my customers was HP Education. I did a lot of network training, and it became one of those things that made a little bit more sense for me to join the organization. I am not representing HP Education Services tonight. I'm Jeff Carroll, tech, man on the street, okay, with some stuff to talk about. It happens to be a bonus week for me, though, because I'm delivering an SDN class, and I get to do SDN tonight, and I've been doing it every night for the last about 6 or 7 nights, so it's just like SDN, or OpenFlow, a lot of Wireshark. So, to me, like I say, it's a bonus. I get to play with it. It's fresh from that perspective. So, some standard kinds of questions. Who's doing SDN? Like, really doing it in production right now? A hand. Why are you here? You don't need me. You should be up here talking about this. So, well, okay. Who's thinking about it? Well, I listed about another sounding 3 hands. I have no clue, but it sounded interesting. I have nothing else to do tonight. Let's go hear Jeff go on about SDN. Who's ever heard me talk before? Oh, no, you haven't heard? Woo-hoo! The story hadn't gotten that far yet. I'm saying, after tonight, you may never come back. Jeff, just go, forget that nonsense. I'm not going to do that one again. Please. Who let him in? All right. Another question. Who looks at packets with any kind of protocol analyzer on a daily basis? On a couple of times a week basis? Only when something is broke and you hate it. And the rest of you don't use Wireshark or any other packet type capture or detailed utility. And that's okay too. You don't have to. But if you're a network person, it's inevitable. Wait, how many network people do we have in the room again? Those that didn't raise your hands, you must be server people. Why are you here? This is network folks stuff. Okay, fine. Server people may want to meet with network stuff too. That's okay. And how many network folks are also server stuff? Yes, it is.
Not by choice.
If something doesn't work in the network, who gets blamed?
Network.
The network. And whose fault is it never? The network. But the network folks have to prove beyond reasonable doubt why it's not the network. Right? And that means we have to be more knowledgeable than just teamwork from here to the server. I'm done. Network's golden. That was last century. Okay. We don't get to do pinging from point A to point B proves nothing because when everybody hits the go key and it doesn't go, the network's down. The network's broke. And we got to go figure out, I know the network's not broke. If the network's broke, I'd already be working on it. I didn't need to tell anybody else external to my group to tell me the problem. All right? I'm already working this thing. So now I've got to be a little bit more knowledgeable. Thank you, your favorite search engine on the internet. Right? Let me Google that for you. I can find an answer. Right? Sometimes, most of the time, you can find something. But we might have to go in and look at the packets and trying to figure out why in the world is something not working that I really don't know why, and I can ping. And maybe I can do more than just ping. Maybe I can do a little bit more stuff. But I'm pretty sure it's server or application or desktop. It's all those other groups. Well, it's not the network. Well, maybe not always. Right? There are sometimes you have to do it. So this is not really about that kind of depth and detail. However, from the aspect of implementing a new technology, how do you know if it's really working? Well, as long as everything is green that's supposed to be green, not red when it's not supposed to be red, and packets go from point A to point B, the network's up. It's working. Yeah, except for those new things you got to learn a little bit more about. And that's a little bit of what tonight's about. There's been some sessions previously, and recently, talking about SDN, network automation, net DevOps, blah, 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 okay? And they've been at varying levels. My level is saying, let's look at the packets. Let's see what some of these packets look like. In one particular facet of this, in software-defined networking, and very specifically, protocol issues, OpenFlow. And just see a little bit of what goes on here. And that's really what my focus is about. I'm about trying to save seconds here and there. when there is a problem, it's not my fault, and I'm trying to get everybody off my back and go, it's there. Whatever the there is, I don't care who the there is, I just want to be able to say, here is what I know, the packets don't lie, and this is why I think X. So I need to understand the underlying protocols for just about everything. And again, if I don't know something, Google's going to help me out, or some search engine environment's going to help me out to do that. So that's a little bit of what tonight's about. Let's see what this underlying protocol is. That will foundation understanding of what's going on in this SDN world. SDN is another one of these what I call stealth technologies. It's like IPv6. IPv6 has been available from a production internet viewpoint a long time, since 1999, logistically and really, and way more available of recent times. SDN has been around for a good half dozen years, maybe a little bit more. But everybody's first initial thinking is, why do I need SDN? I know how to go configure my switches. This SDN thing configures switches from a GUI. Who is a CLI person? Die hard. There's an absolute, no offense to anyone, age differential between those that love the CLI and those that love the GUI. Okay? The old guys like me, we started in the CLI. We started in network in computing before there was a GUI. You know, the GUI's for the people that don't want to do the CLI. Now we're in this mode of, well, there's some things that are GUI, there's some things that are CLI, and SDN feels like I'm giving up something. It feels like I'm giving up CLI. It feels like I'm giving up I gotta go touch every box to do a configuration job. Or maybe I've got some automation scripts and whatnot running. SDN can provide a different aspect of network configuration, network operations, and to a lot of people, it feels like now I gotta be a programmer. Now I got to do this. Now I got to use a GUI. I'm not going to use my CLI anymore. No, thank you. I don't need that. Okay? That's not what my talk is about. My talk is to say this is how things work. All right? Here are the particulars in a mostly generic state. Okay? What does OpenFlow do? What does it look like? And how does all this stuff work together? So from a kind of a generic viewpoint, it doesn't matter the parts and the pieces. Okay, and I'll talk a little bit more about some of the parts and pieces in a minute. So with all that said, you want to stay still? Okay, I'll take it. You didn't get up and leave yet, so okay, so far. So, a little bit of what I'm going to call basics. Some of this may be a little bit of a repeat. Talk a little bit about what SDN is, a little bit about OpenFlow. Really, again, I'm focusing on the OpenFlow protocol and looking at OpenFlow from a packet perspective, looking at it from Wireshark's perspective, okay? What do I see? But more importantly, what do I care about? What are the important things to understand here? Now, part of this whole software-defined networking aspect, and I kind of alluded to it a minute ago, is to decouple, let's just say, the control plane / management plane away from each individual switch. Let the switches do what they're best at, quote unquote, switching. And let's let something else sit above to help make the decisions of what we want to be doing with our traffic down at those switches. So this control plane mechanism is effectively taking the generic smarts away from the switch, and let's put them up at a controller, an SDN controller. And the SDN controller is going to talk to all the switches that are out there and is effectively going to send flow definitions. Or you could loosely think about them like ACL or firewall rules. Loosely, okay? Don't say, well, Jeff said you're doing ACLs. That is not what I said. I'm just saying from an analogy viewpoint, we're going to set up it here a little bit higher with this controller and say, I want traffic to maneuver around in my network such and such a way. The traditional way before tonight, Jeff talk, was you go to each switch, you log in, you do the config, you go to the next switch, you do the config. And that config, it may be things like I want to put ports into VLANs, I want VLANs to have IP addresses, maybe I want some routing here, maybe I just want some VLAN traffic maneuvering, maybe I wanted some QoS settings for voice traffic as opposed to data traffic, except for my data traffic, I want high priority QoS. Are we good on that one? You should want the same. Your traffic should always have higher than everybody else's priority, because remember, if there's a network problem, I got to get in there. So that's my justification for I get high priority traffic over everything, especially over voice. Because if I'm running a voice network, I want that to be down because nobody can call me until there's a problem. You ever think about that? If the voice network is down, they can't call you until it's down. Woohoo! Until you start feeling the rumble of the pitchforks and torches coming down the hall, and they're after you because no voice network. All right. So anyway, we're trying to sit up here and basically say, let's not necessarily deal with going out to all these individual switches, regardless if they have common configuration, which by and large, if we think about access layer or edge, most of those configs would be similar. Maybe not identical, but they would be largely similar. And a lot of people by this time, we're into the latter half of the second decade of the 20th century, well, I'm probably not going out there to 500 switches one at a time unless I'm by the clock. If I'm paid by the clock, there might be a whole, if I'm a contractor, no, we're still not. We're going to do it the smart way. We're going to have some scripts and stuff. SDN is, and kind of its overall concept, actually is taking that to another level. Okay? And I'm also not just generically saying right now that I would use this controller, throw a quote config, because it's not actually what's going to happen. I'm going to send these flow definitions that tell the switch to look at certain traffic and do something with that traffic as you see it. So again, that's why I like to say it's loosely kind of thinking a little bit like an ACL. And then do it once and done. That's the traditional, you go config the switch, you're done until there's some reason to make a change, right? When corporate real estate said, hey, we're going to move the accounting department from the 3rd floor east wing to the 5th floor south wing tomorrow, right? Or tonight, so that they're done tomorrow, which means, oh, the network team always gets notified last. Right? So we're up here at 3 in the morning because somebody caught wind of it, and I just happened to stupidly look at email because I was still up at 3. Right? Oh, great, now I got to go make changes. SDN is not just thinking that way. SDN is another way of saying, I can do this programming of the switch from an almost dynamic or on-the-fly viewpoint. For instance, let's say I've got some configuration on the switch to do X. But now I get some sort of packets come in and they don't match anything. They don't match any of these definitions. They don't match a config that I've got running. Typically, traffic like that would probably just get dropped. In this SDN world, I can actually redirect that traffic up to the controller, and the controller might be capable of interrogating that traffic and say, oh, I know what to do with that, and push down a flow definition to the switch to say, process that traffic this way. We can also have applications that can do things like this. There are some of the DNS entities write some SDN applications to some SDN controllers to basically have DNS traffic redirected up to this DNS top. And then it sits there and interrogates where the destination requests are going. And if they're going to badguysite.com, we probably don't want to send that traffic there. All right? So we might send down to the switch, say, oh, if you see that traffic, send that request to a redirect page that says you are not following corporate policy, stay where you are, security's on their way. Now, if somebody saw that on the web screen, what do you think they're going to do next? They're gone. They're going to turn off their monitor, they're going to try to flip to another web page, and they're out of there. This is a little bit of movie stuff, but I'm not that far off, right? That password's on the bottom side of the keyboard still today. Anyway, so all this stuff is relative. So this SDN kind of overall thing gives us more capabilities than just the standard, let's go configure our infrastructure. That was kind of its first roll out of the gate, because initially the roll out of the gate was, hey, we got all this cool stuff, but it's not fully blown through yet. I.e., we didn't have these applications. We had to do our own extra work. And that's where the initial ideas of, oh, I got to be a programmer came from. I am not a programmer. I know I'm not a programmer. I took some programming classes in my early days because I was working in an environment where I did the hardware, had a software engineer, and I wanted to be able to prove what it was not. It wasn't the hardware. But I had to know enough about software to be able to talk to software folks and say, why it's their problem, right? So, but I know I'm not a programmer. So I don't want to do those kind of things. But things are evolving in this SDN world where we get these kinds of applications like the DS, load balancing, all kinds of other applications out there. And it's growing more and more. So SDN is starting to become that noise enough thing of, let's go look at it. Let's put it in the lab and kind of play with it, see what it does in our world, see what it can do for us in our environment. So that's what I want to kind of say. If you're going to start playing with it, the things to look for. So we have the controller that now basically communicates down via OpenFlow as a protocol to the switches to provide these switches this configuration, these flow definitions to say, if you see traffic that matches this, do that. Okay? And then you can test on anything and do just about anything with that traffic. I can send it out a port, I can redirect it, I can drop it, I can send it multiple places, I can do lots of different things. All right, from that particular viewpoint. And we tell the switch. And actually what you get now the capability is a layer 2 access switch making up to well past layer 4 decisions, which is traditionally not what we do. All right? We traditionally have layer 3 plus decisions go to a box upstream. All right? Here's a problem with that thinking. That traffic is now maneuvering through the network before the decision has been made of what we really want to do. And if it's traffic that, like, say, DNS, it may move even further into the network. It moves over into the server farm. All right? If it's something even beyond that, say it's headed to external, it maneuvers all the way to the firewall before the decision is made. And what we can potentially do with this new concept is put that decision at the entry point of the network. That's what security is about. That's what we get with this capability. Because now I can configure this switch out of its normal type configuration world, where it can't do, if it's an access-only layer switch, it only looks at MAC addresses. All right? It pretty much doesn't care about the rest. Okay, maybe you did a little bit of light routing out there. Okay, but still, you can't, from the switch operating system perspective, do much else in a regular switch capabilities. That's what we can do now with SDN. So here's a little bit of a kind of a diagram. The controller pushes down this information, basically flow definitions, via the OpenFlow protocol. And then depending on some more variables, depends on how many flow definitions a switch can have. Is it processing flow definitions in ASICs, or is it processing it in software through CPU? Can it do both? Can it do some of it in ASICs, but more detailed looks has to go higher up into the CPU and software? So there's many variables that can come into play as to how this can all work from an efficiency viewpoint. That became one of the other things that everybody thought about from this SDN. Oh, great. I'm losing my ASIC functionality of wire speed type actions, and I've got to go up into CPU. Well, let's just go back to the middle of the last decade of the last century where we were at that time, right before wire speed technology really became available. So no, we can do some of this still at wire speed, and we can do other things at less than, but sometimes that less than is minimal enough because, again, I'm controlling at the entry point of the network, not somewhere else further up in my network, where it's logistically too late, right? There's some traffic, if it gets up to distribution or to core, it's too late. The bad stuff is already there, all right, or potentially there. Yes?
The OpenFlow protocol, is that still the most popular, or is it being supplanted by other protocols between the controller and the channel, or in the switch?
So let me summarize the question a little bit and reply. So the question is OpenFlow the only protocol that's used, or proprietary? I'm going to kind of add a little bit to your question. Sure. Okay. And the answer is OpenFlow is an open standard. So it's not proprietary. All of the main networking vendors, plus a lot of other entities that are supporting this kind of capability, not just switch manufacturers, are supporting OpenFlow. Generically, most of the manufacturers are not doing anything else anymore. If they had been, they're pretty much moved to OpenFlow because it doesn't make sense to do it proprietary. From the traditional SDN look, there is no other protocol. It's OpenFlow. So with it being an open standard, and most of the networking vendors are on board with it, not only on board, but they all participate to it. It makes it more universal from the aspect, I don't have to specifically have a manufacturer's controller and a manufacturer's switches. Now, with that said, there are varying operational characteristics that might be better when it's an all-vendor vertical solution as opposed to a multi-vendor solution. So I'll at least leave that caveat. Some of the manufacturers, networking manufacturers, have more capabilities, more feature with this operation when it's all of their solution. But generically, it's open. And the nice thing about this open is I can pretty much grab anybody's controller and anybody's, let me rephrase it, anybody's OpenFlow supported controller and anybody's OpenFlow supported switch, and they can all talk together. It just depends what can they all do. The older technology switches that do support OpenFlow don't have the same capabilities typically in ASICs that newer technology switches do. So yeah, like I've got some older switches, they support OpenFlow, but they can't do a lot of the new cool things because their ASICs don't have it. That's probably one of the biggest things. Everybody says, oh, I'll just implement OpenFlow in my existing infrastructure. There needs to be a big fat period right there and say, for research, right? Because there may be some older switches that cannot even do it, or they can't do what you want to do. So then it becomes, now, okay, now what do we have to do next? So it's a longer answer to your question, but it's an open standard. And kind of sort of with that, because it's a great little point. There's multiple versions of OpenFlow. Like everything else in our world, there's always newer versions. And most of the vendors, both at the, I'll say, switch level as well as the controller level, are not actually supporting the latest version. And I don't know why. The two predominant versions, there's 1.0, 1.1, 1.2, 1.3, 1.4, 1.5. Most of the vendors, both at the controller level, either those that make their own or there are half a dozen open source controllers, you don't have to get a vendor specific, as well as the infrastructure guys are supporting 1.0 or 1.3. Now, 4 and 5, I really haven't even spent enough time looking at the standard because if nobody's really supporting it, it just doesn't seem like I need to spend my time looking at it. 1.0 to 1.3, there was a big jump. And the 1.3 gave us a lot more capability with what they call the flow tables and being able to have multiple tables, being able to go from ASIC to CPU processing, et cetera. 1.0 was fairly plain vanilla. But somewhere between 1.1 and 1.2, they also added IPv6 support. They added the flows in 1.3. And it seems like most of the vendors kind of went, okay, yeah, we're doing 1.3, we're good enough for now, is kind of the way I view it. As what I see. There's that piece. And really, what I want to play with and kind of talk about today is looking at this OpenFlow communications channel and then see the different types of messages. We want to see how everything starts talking together. We want to see when they are talking what they're exchanging and who starts and who finishes, et cetera, or who replies the call.
So whenever we have a new version of OpenFlow and we want to have the hardware supported, so most of the time it's a hardware upgrade, or do we also have a software upgrade which upgrades the OpenFlow version supported by the devices?
D, all the above. So, another good fair question. If, let's just say we want to go to the newer version of OpenFlow. Typically, your controller software would be an upgrade, your switch software would be an upgrade, and or the switch may not support all the features of the newer version. That's what we have had already in the past from 1.0 to like 1.3. So there's always at least software level upgrades, both controller and switch. There might be the switch that's, say, 6 or 7 years old may not support all of the features of the newer OpenFlow spec. So you gotta upgrade hardware, not a hardware update, it's an upgrade, replace, unrack and re-rack kind of thing. So, is that covered?
Yeah.
Yeah, I think that's why a lot of them haven't done, 1.3's given enough features for what everybody's doing today, right? And so everybody's just kind of stopped at that level. Not everybody, but by and large.
And they're also backward compatible. If I have a 1.6, will it work with 1.3 or?
Well, not really. There'll be some. Okay, let me see if I can answer that actually a little bit differently. So the question is basically, if I've got 1.6, let's say, would it work to a 1.3 switch? 1.6 controller to a 1.3 switch. I have to answer this a little bit differently.
Or the opposite, 1.6 switch with a 1.2 controller.
I need to answer it differently. And I need to answer it actually this way. I need to set an operational specification for you. Because that actually makes a good question, but the operation is different. In this environment of a controller communicating to a switch, they have to negotiate and agree on the version of OpenFlow they're going to talk. Okay? The controllers of today basically can negotiate to either 1.0 or 1.3. The switches, most of the time, you have to designate which version of OpenFlow in the config. That depends. Either they default to 1.3, but you can set them to 1.0, or they default to 1.0, and you can set them to 1.3. So the switch and the controller, on a per communication basis, not at a global, but on a per communication basis, have to negotiate and agree upon the same version. So a switch might be capable of 1.6, let's say, but we won't run it at 1.6. We would want to run it at, say, 1.3 to match the controller. I may have another switch, an older technology switch, that only supports 1.0. The controller could still talk to it, but that switch has less capabilities compared to the 1.3 switch. So it's not that can I have them different? I actually can't. They have to negotiate, right? We have to be speaking the same version. So that becomes part of the difference. Typically, I would say a newer version switch code probably can be set to an older version of OpenFlow. All right. So it may be a 1.6 capable switch, but you would set it to speak to 1.3 if that's all your controller can do. Yes.
So on my setup, I'm running Cisco and an OSC, and mine basically consists of hardware switch, either auto or whatever specific version you want, 1.0, 1.1, 1.2, or 1.3. However, if you set it to auto, the controller will configure the switch to the highest version that it can support.
And that's what a little bit how also the kind of the switch side can fit too.
Yes, but is there a best practice between the hardware and the controller on which one you set? In other words, I want to set both hard like we do auto config on an interface?
Oh, okay, I kind of got part of it. I'll put it this way. Of the literally few controllers that I've played with, the controllers can negotiate based on what the switch says it can do.
Right, but
So the controller is more of an auto negotiation, not the switch.
Yeah, right. But do you want to hard code that, or do you want to just let auto config?
Well,
Is there a best practice?
generically, I want 1.3.
Yeah.
So if I find out my switch defaults to 1.0, I'm hard coding it to 1.3.
Okay.
I don't want it to do. I'm a absolute thinking kind of guy. I don't like auto negotiate, although in the real world, fine, whatever. But typically, I only want one side to do the auto negotiate. Since the controller, my experience, I'll caveat that, my experience, the controllers are more at the auto negotiate by default. The switch I'll hard code.
It's
I mean,
hard.
it works. I'm not saying it doesn't work. I'm just.
Yeah, I mean, I turned it on, it came up 1.3, I said, I'm good.
Yes, exactly. Exactly. So all of these things become there's a little bit of research you got to do here. If you've got multiple switches even from the same manufacturer. You still have to do the research to find out what supports, what it can do, does it auto-negotiate, does it auto-default to one level, et cetera, et cetera. Okay, so, yeah, it's like everything else. That's why we spend time in the labs. Okay, some message types that we're gonna see. Effectively, we've got some messages that come from the controller, that are solicited. We've got some messages that come from the controller that aren't solicited. We also have some messages that can effectively just be, one of them is gonna send a message. It could be a request to do something, a request to find out some status. We even have I'll call it loosely, like an OpenFlow ping, not exactly that. But if a controller's talking to a switch, he doesn't want to talk to it one time and say, "Yep, I see you." You still there? No. There's a little bit more of that little handshake going on, because we need to have that in this SDN world. So there's a little bit of kind of underlying background traffic. Oh, are you there? Yep. Are you still there? Yeah. Actually, it doesn't ask, are you still there? It just asks, are you there? Right? And then if it goes away, I know he goes away, the controller knows he goes away, and it goes, that device is no longer available. Right? We can't talk to that anymore. And he comes back in, oh, there he is, hello. Right? So these messages that go through, symmetric, the asynchronous, and the controllers to the switch. So, first off, a couple of messages here. Controllers, I would say at a generic state, do not get pre-configured of the switches they're going to talk to. That is not the way this works. The controller lives up here and it's going to be alive. You configure the switches to talk to the controller and the switches start. Controller, are you there? Hello, controller. And oh, by the way, I'm a little bit of information about me and my version of OpenFlow and a couple of little tidbits. And the controller says, ha, I see you. I can speak to you. I can come to you. We can agree. And then it becomes a little bit of a quick flood. The controller saying, okay, tell me about yourself, Ken. What can you do? And da-da-da-da-da. And I'm going to go ahead and give you some flow definitions, perhaps. I want to kind of kickstart you into an operation here. All right? So the hello starts from the switches. Yes.
So is that controller then configured on the switch ahead of time, or is there a discovery process?
I have to configure on the switch to talk to the controller's IP and on a port and a few other tidbits.
Okay.
Yeah, you have to do this. So this is, I'm not going to say the chicken and the egg, but it's a little bit different from a network management thinking viewpoint, right? Network management, we can either typically go out and do some sort of, auto discovery, ping sweep, all right? Or I can go in on a point-by-point, device-to-device basis and say, network manager, go see if you're there. Oh, it's out there. Okay, fine. Then we can negotiate. This is the opposite. The controller, pretty much you want to fire it up, maybe just have it up there ready, and then you go to the switches and put the config down. Using your network management application, right? Because it can blast a bunch of big config stuff like that out, or however you want to do it. So yeah, you have to configure the switch to go talk to the controller. You see, the nice thing about this is, again, in a lot of generic states, we're talking about maybe 4 to 8 command entries, right? It's not like it's long and drawn out and variable. Most of our stuff is not that complicated. If everybody knew how easy this is, everybody would be doing it. Aren't we glad they don't know this? Right? Basic networking, pretty easy. So we've got these hello packets. We'll see some of these. We've got these little echoes. That's the are you there, that the controller will do after it has started calming with a switch. We have some other messages that go in here. We'll see a few of these. A flow removed is just what it says. It's basically a switch that's informing the controller, I've killed a flow entry. Now, why in the world would you think a switch would kill a flow entry?
It doesn't recognize it.
Client isn't there anymore.
Yeah, speak up a little louder.
Offline.
Client isn't there anymore?
Yeah. There could be timing, because you can also have flow definitions that are timed to live for a certain amount of time. It could be that the controller actually asked the switch, or really told the switch to remove that flow entry. So this is the switch saying, I'm removing a flow entry. depending on some variables, if the controller dies, what are these switches gonna do? If they've got flow entries that are timed, they're gonna lose it. They're gonna send out a flow remove message. It's gonna die because there's nowhere to send it to. But then what happens with traffic? And that becomes a little bit of the switch platform. Some switch platforms have the capability of a hybrid mode to say, oh, well, I lost my flow entries for my SDN OpenFlow Controller ports. So any traffic that comes in those ports, I could either let it go through the normal switch processing or drop all those packets. Now, depending on which network that represents, depends on what you're going to do with those packets. All right? If it's my network, no, we want traffic to still flow. Maybe less than optimal, maybe not be tested, but I'm not losing my traffic. Accounting, if it's Friday, print check day, no, we want to keep accounting up. All right? Never mess with accounting. You do not make the money people unhappy, because you will never get your stuff that you want. All right? Marketing, who cares? Sales, mostly who cares? Manufacturing, let's kind of keep manufacturing up and running, right? You get the idea. All right? Flow entries live, and we can deal with the operations in a couple different ways. Port status is pretty much what it just said, and there could also be the function of a controller telling a switch, here's a flow entry, and the switch going, no, I can't do that. That's not possible. So you get an error message back from the switch to the controller saying, try something different, this one's not going to work. Now, hopefully, depending on, again, some variables, the controller would already know what the switch is capable of and would not try to push a flow definition that the switch couldn't do anyway. But like everything else, there's always an exception to the rule, or to the thinking of it. Features, we'll see some of these messages. Configuration, we'll see some of these. Modify state might be that. Switch, you could do X, but I'd rather you do Y instead. I'd rather you do maybe a little bit different of an operation. So you might see some of these type of messages. This is just the kind of the info. You'll find this in the standards definition, which is one of the documents that's either on the flash drive or up at the box.com site, just to have it handy. Packet out, barrier role request. This barrier message is a very interesting one. When a switch wants to send a flow definition, when the controller wants to send a flow definition to the switch, it sends out a flow mod packet. And then typically right behind that, the controller will send a barrier message, which basically says, did you complete what I just told you to do? And the barrier message is what prompts the switch to reply back to the controller and say, hey, I just did this configuration. A flow mod by itself does not require a response. Flow mod from the controller by itself does not require a response. That's what this barrier message is basically for. So I can send a flow mod and just be done with it. But traditionally, the controllers are going to follow up with this barrier. Did you do it? The switch will reply back with, here's what I just did, which effectively is that flow mod configuration.
Question. This OpenFlow communication, is it on UDP, TCP, or something else altogether?
So OpenFlow, great question. Is it UDP, TCP, IP? Who knows?
It would be IP, you said IP.
No, I'm just, as choices.
Yeah.
So, who knows the answer?
UDP.
Okay, this is fine. So let's go through. You think this is UDP? You think about kind of what I've already talked about? Who thinks it might be TCP?
You won't have the barrier message.
Who thinks it might be something different than either UDP or TCP? These are all okay. It is UDP. Now, with that even said, which is a great question, there are two different ports that have been defined for OpenFlow use. The original port was kind of like by the Open Standard Group, 6633. And then a little bit later on, IANA came through and said, no. 6653. 3353. Really? They didn't ask me. Of course they never asked Jeff. Why did they even have to change it? I've guessing IANA had something else that 6632 was doing. Probably do not, because why would an open standards group go grab a port that was already defined? Again, they didn't ask Joe. So this presents a little bit of another kind of issue, really, in setting up a switch to talk to the controller. Not only do I need the controller's IP, I need to understand the controller port that it's going to be listening on. More of the environments of controllers and switch codes support 6633 still as the default, but it is not guaranteed to be that. Some of the, at least one of the open source controllers defaults to, actually, is only configured for 6653. So of course, Jeff firing up, and I can't remember, I think it was either Open Daylight or Floodlight, I can't remember which one. So if anybody knows which one, the bottom line is, I configured my switch as normal, I fired up this new controller, and nothing. Really? Fire up Wireshark. Oh, here was the hello message that the switch sent up to the controller, and no reply. Oh. Now what do we do when things don't work? Google it or read the book. Because we're smart folks. If we can't figure it out without reading the book, I don't belong here. And when I worked for Foundry Networks back in the day, I can say RTFM with a straight face, read the Foundry manual. And it's really cool to do that when you're around layers 8, 9, and 10 kind of folks. Because you just big wide. The vendor just said RTFM for one of my people, and then you follow it up with, yeah, read the Foundry manual, though So I had to look it up and find out that controller only supported 6653, so I had to reconfigure my switch to not only talk to that controller's IP, but at port 6653. So this is another one of these little things you'll discover. It appears that most of the switch codes support either, but they typically default to one, the 6633. The controllers you got to find out. Just match it all. And
is it then configurable? Means I can have a custom UDP port after that or not?
Not to my knowledge. It appears, I'll say from this perspective, from everything I've seen about controllers, they are fixed. You can't, of the controllers I've played with, which is like a few of the about dozens that are out there, they are hard-coded. Now, can they be changed? I don't know. There's not a command line option. There's not a configuration option to change. Some things about port types. Now, you may kind of go, it's a switch. Please, in our world, there's more than just physical things, right? Because I can also have virtual switches. Who's playing in virtual worlds? Who's got VMware, ESXi running, or whatever that Microsoft thing is, Hyper-V, and you got virtual network stuff going on there, and love it. We hate it. We got no visibility into that. Those servers are sitting there flying around traffic and never leaves out to the physical world. All right? It must be the server problem then, because it's in the virtual environment. It's not mine. So it's not a switch. I can't touch it. It's not my problem. Yeah, again, that was last decade. All right? If it's networking, we're blamed, even if we didn't set it up. Anyway, so we have different kinds of ports from a perspective of this SDN and OpenFlow functionality. I need physical ports. I need virtual ports. I also have other kind of ports in a switch, like a loopback interface, right? I have other kinds of port definitions in a physical switch, like aggregation interfaces, ether channel, bridge aggregation, link aggregation. Anytime I've taken multiple physical interfaces and made one logical, all right? I can have tunnel interfaces that are actually used in this SDN world, GRE-style tunnels. So I've got to support all kinds of different interface types in this environment, in addition to real virtual type switches, virtual technology. All right, so that's a little about. And from an OpenFlow perspective, the controller can effectively tell the switch, you're going to have some of these reserved port definitions. These things like controller ports, meaning I'm looking at some traffic, and I want to ship it to the controller for further decision making. Because switch, you can't do the job. So I need a controller port to send traffic out on. And so that leaves a physical world, but it's a logical definition saying we're going to the controller. I could also send it to a few other types of ports. Yes?
one of the use cases that we use it for is, in a virtual environment, VMware, one of the challenges we have is if we're trying to troubleshoot a problem there, setting up a traditional span port, you overrun it really quick with a cluster. And so OpenFlow would allow you to, by setting up specific ports, allow you to kind of delineate or filter your span. So instead of getting the whole drinking from the fire hose type of thing, you can only get very specific things by controlling it through OpenFlow.
Yeah, I mean, that's one of the great costs. And it doesn't use traditional span mirror technology. So it doesn't take those kinds of resources in a virtual or physical world. So this becomes some of that cool thinking of things I can do with SDN that I can't do in a traditional switch code environment. Okay? Kind of vendor independent there in thinking. I can do something else with a switch that I've been lightly toying with. I can make this a layer 1 patch panel using OpenFlow. Now, it may be an expensive looking layer 1 patch panel, but if you've ever priced out real layer 1 patch systems from like MRV communications, they're more expensive by port than switches are.
Not portable.
So I can just basically sit here and say, traffic comes in here, I want it to go out that port. Oh wait, I want it to go out a different port. And I can have these ports connected to other different areas. So yeah, you may kind of snicker and laugh, but how many times do you have some leftover ports on switches?
You kind of making a cross connect out of it that way?
Say again?
Are you kind of making a cross connect out of it that way?
Yeah, you can make a cross connect out of it. So like in a lab rack, sometimes you need things interconnected different ways different times. What do we traditionally do? They take the time to go figure it out, we reattach it. And then about the time you got it all dialed in on Friday afternoon, you're going to remote access on the weekend, and you get there Saturday afternoon finally after you've done all the mowing and the yard work and the hot you really don't want to play, but you know you got it. And then it's like, uh-oh. I need the primary connection from there to there, and I missed it. And you're not going back. So they're, okay, fine, we're going to play in the pool instead. Anyway, we should have been doing that regardless, but nevertheless, yeah, you can make a cross connect out of it using SDN and OpenFlow. Again, it may sound a little silly, but depending on a lot of variables, switch ports are cheaper to do that with. You know, whether it's live or production doesn't really matter, but it's another kind of capability. Because it doesn't, I'm not even interrogating what kind of traffic, I'm just saying anything in this port, go to that port. And it's almost the same thing as making it look like span mirror functionality. Except now, I can tweak it as commented to say, no, only look for this traffic coming in here and ship it out to my tool port, right? And especially from a virtual world to a physical world, we can do those. So this is all great. Now you're starting to get something, okay, now there's maybe a little bit more to this story than just the traditional thinking of how I might use it all. So here's a nice little slide. I kind of saw somebody else's light description and came up with this to basically show the flow, who talks to who, what foundation message types do you see, right? And it kind of I'm not going to say exactly top down, but we kind of start with about top portions. We got the hellos, we got some, controller now knows about the switch, I need more of the story. I need more of what you're really capable of doing. Not just that you're there and that we can speak the same version of OpenFlow, but I want to know more about you so that I can program you correctly the next time that I need to. And then there's some other, I'll call it foundation handshaking that goes around back and forth. And that slide is just not very visible, as they say. So, effectively, this is the mode. Let me see if I can move that around just a little bit. This happens to be an OpenFlow controller that I have the most experience on. It is made by HPE, all right? But part of what I'm showing here is that I'm talking to a couple of different brands of switches. I'm talking to the now known as Aruba networks, part of HPE networking, so they call them, the switches are called Aruba in the newer versions. And I'm talking to another switch that's identified by the Nicira. The Nicira was one of the early developers in all of this kind of OpenFlow and then what they called Open vSwitch, Open Virtual Switch technology. Open vSwitch gives me the capability of taking, say, a Linux box and dropping Open vSwitch on it, so now it has OpenFlow capability, and so now I can communicate to that switch with a controller. And it could be a Linux computer, it could be a Linux box, it could be whatever. Nicira was bought out by VMware, but they keep still that Mac ID is still known as Nicira by and large. But this is to basically show, in this case, I'm talking to two different switches, what version of OpenFlow I've negotiated, and a little bit more information. A controller knows about a switch based on what's called the DPID, the Data Path Identifier. It's an 8-byte address. The first 2 bytes, I kind of refer to as the prefix, are provided by the switch, and they're provided in different ways. They can be provided in just incremental numbers, typically starting with 1, as we see in the second byte. Well, actually, we don't in this one, we see further down, but we see that this is 0000, but it's 2 different, it looks like 2 different switches from the same IP address. All right? The last 6 bytes are the MAC address of the switch. Has anybody ever seen a real switch with a MAC address 1 in your life? Or 2? Now, they're typically a mix of numbers, right? This tells me a couple of things. 1, I must be changing the MAC address, which we don't typically think of doing on a physical switch. So this is probably something else. It happens to be a switch emulator. It's an open source technology called MiniNet. And MiniNet is a way to play with this SDN environment with OpenFlow, because you can run MiniNet as a virtual, you can run the controller as a virtual, and you can do all this on VirtualBox or VMware Workstation or VMware Fusion or whatever other virtualization technology, ESXi or Hyper-V or whatever.
It's free, right?
And it's free. Absolutely. And even more importantly, not only is it free, is it supported by any OpenFlow controller that I've seen, you can build up to a 4096 switch environment with MiniNet. You can actually potentially build your real network out of MiniNet all on a computer. So it's very, very cool, very, very capable. One of the nice things that's handy with MiniNet is I don't need any physical world. I don't have to deal with a physical world. I can kind of do with a little virtual, even just as a validation that my controller's working to the degree that I think it is. And I can actually pipe traffic out of this MiniNet virtual world to a physical interface and get traffic in and out of MiniNet. It builds logical computers that you can, little Linux-based level computers, you can actually access and use. So it's very, very cool, very, very capable. Mininet.org, I think.
If you Google it, it's like your own.
Google it.
Yeah. So I'm just saying, it's your own. It says you build your own cloud, and it lets you download. It's pretty sweet, pretty simple.
Yeah. I mean, MiniNet it's just a very cool utility. I'm not going to say right out of the gate it's one of the easiest things to use. It takes a little bit to kind of understand what they're doing, because it's all kind of a command line which you fire it up to build this configuration. But there's a lot of cool information you can find about MiniNet out there. So this real controller, or this controller that I've got, and a real switch that I have, and a virtual switch emulator. It's not a simulator, it's an emulator. Okay? And so I've got a couple different things represented here. So also in MiniNet, you can say, don't use traditional looking MAC addresses. It's got basically a flag to say, start my MAC addresses at 1 and count up. So it's a lot easier to look at that and go, switch 1. I know which one switch 1 is, right? It's MAC address 1. Woo! Life is a little easier from a lab testing perspective than looking at that other MAC address and first off going, well, that's more than a MAC address. Yeah, the first 2 bytes are representative of a what they call the instance, and then the last 6 bytes are the MAC address. So in this case, I have 2 switches, but because they're the same instance ID doesn't necessarily mean anything. They are still 2 different looking switches on a single IP. that kind of gives me that mode, that's MiniNet, or some other kind of perhaps switch simulator. I've never used anything else, I've only ever used MiniNet.
But how will the communication work? Because they still have to have that UDP communication between controller and switch, and that would be on an IP address. Huh? But if they have the same IP address,
They're not the same IP. Well, yes, they're same IP, but they send out different DPIDs. And it works.
oh, okay.
Yeah, the data path identifier, even though it comes from the same IP, is different. Because, actually, if you pull up a screenshot, I can take my real physical switch and create different instances. So my bytes will be different, be the same MAC address, same IP address. But because of the different instances of operation. So let me back up a half a second and comment to a couple of things here. Generically, an SDN implementation is not an all or none solution at a switch. The early days it was. Today it is not. I can take the switch, physical or virtual, and do one port being controlled, or all ports, or anything in between. All right? Typically, I will make the selection of doing that based on VLANs, putting ports into VLANs, and then in my OpenFlow configuration on the switch say, this VLAN is going to be the OpenFlow controlled VLAN, and all ports in that VLAN are going to be part of OpenFlow control. All ports that are not part of this VLAN, let's just say VLAN 10, all right? All ports that are not members of VLAN 10 are not under OpenFlow control, they're under standard switch processing, done. VLAN 10 can have one port, no ports, or all ports, and everything in between. So that's one of the things that gets kind of a base level decision making, is that part of my config I have to do that. Anyone have that, guys? Something else, okay. We got a couple questions here.
Yeah, for my implementation, what I did is it's called hybrid mode, where you're taking part of your switch and doing SDN and part of the switch is legacy, regular VLAN. What you do, when I implemented mine, is start one port at a time to get it to work. And then you migrate the other ports into SDN, because the way we did it is we turn it on. We just put in the config, your little bitty config in the switch. It goes off the controller grade. Floods the entire network with all these updates. And does it because it doesn't update the first time. So now you get this flood. So what you want to do when you implement this is you want to get your switch talking to your controller unconfigured. So the only thing you see is your switch ID in the controller, and then you start migrating, adding ports onto your switch to the SDN controller. And that's probably the way we worked. It works great.
And that's part of what I was going to say, is doing that very exact same thing.
And absolutely. And that was one of the big things for hybrid mode.
I'm just curious about how does it handle trunk ports with tag ports?
So
Can I just say it
second
does and be done with it, or do you want more details? No, it's fine. It handles it very well. Is that good enough? No, it's not. All right. So generically, the question being, how does it handle trunk ports, which I'm assuming you mean 802.1q capable ports.
Correct.
Because trunk means different things to different vendor areas.
Correct.
But nevertheless.
That's why I added tag.
And aggregated ports of physical looking like one logical. Okay, so let me answer the question in two ways. OpenFlow into itself does not care if that port is speaking traditional Ethernet frames or tagged frames. Does it? No, doesn't care. So that will say it's just a port. Trunk or aggregation interfaces get also defined then as a logical interface. So if I take ports 7 and 8 and put them into an ether channel, I define an ether channel port ID, and it's now a logical port. Agreed? Everybody better be saying yes, right? If you've gone through training or playing with it. So the switch reports that logical port ID to the controller. It doesn't know that, the controller does not know port 7 and 8 are really my trunk 1 or my ether channel 1. And the controller doesn't care. The controller says, you've told me about E channel 1. I'm gonna tell you to do something with E-channel 1, you deal with whatever E-channel 1 is, right? And let the switch will do its normal distribution of traffic across port 7 and 8. So we don't have to deal with that in OpenFlow or with SDN, from a controller viewpoint. You could potentially change that configuration. This is where it gets even more interesting, because switch technology will do a load distribution across ports 7 and 8, but it is not an absolute exacting. It still may have one physical interface more weighted of traffic than the other because of the hashing algorithm. And we have some controls, but maybe not absolute. It's not a load balancing thing, like a load balancer. You can actually deconfigure that ether channel and basically say, from a SDN and OpenFlow configuration, say, I'm going to put these ports into a group definition, and I'm going to let some flow information distribute my traffic across those two interfaces. But if the other end is still thinking ether channel, you can't do it, right? So there's a little bit of issues in doing all that. If both ends were configured that way, it would work, all right? So, but there's, again, some things that can be thought of how I might change my traditional way of building and doing it slightly different, if it makes sense. But another component that gets handled in here is, what if you've got spanning tree enabled because you have a design loop on purpose? Spanning tree is a higher precedence than OpenFlow. But the switch will report to the controller, these ports are in a block state. So the controller still gets to know about them, but it will not put a flow definition down to say, use a port that's currently in a block state. So that would be, duh, sending my traffic to a block port. Really? That's dropping traffic, right? So the controller gets to know about kind of the layer 2 configuration, layer 2 operation of the switch as well. All right, and that's part of what goes on.
You mentioned that we can run a switch in a way some ports are OpenFlow managed and the other ports are not OpenFlow managed.
Absolutely.
So the ones which are OpenFlow managed, would I be running spanning tree on it? Shouldn't be, right?
You can, you don't typically though, which is a great question. You wouldn't typically run ports that are part of OpenFlow control in spanning tree, but you can.
And then
OpenFlow knows that there's a loop, but won't allow the traffic to flow because there's only traffic flowing when it's told to flow.
So it knows there are some people who might do it.
Yeah, perhaps so. This, again, is just this controller view, and the next little slide I want to show right quick, which again is going to elicit a slight change. I can't get this the way I want it exactly. This is not going to work. Hang on just a second. Let's see here. Well, we'll do it this way. This is the controller's view of a switch of this flow table. And I'm not going to delve into this extremely deep, but I'll kind of show that this particular switch has, at least what you can see at the moment, 2 different table IDs. A table ID of 0 and some table ID of 100. This right off the bat, and this is the only information that I was given walking in the door, and somebody said, based on what you see, which version of OpenFlow is this switch controller using? 1.3. Multiple tables. Is not available in 1.0 OpenFlow. Little tidbits. These are tidbits. These are these, I'm going to save a few seconds of asking questions, right, based on some quick information that I get. I don't have to do much else. I saw it on the other screen too, but I can also see it in this flow table. This particular flow table with these entries, flow table entries are not processed in the order that you are shown them. They are processed in priority order. Which the unfortunate part is, the way you see them if you run, basically show my flow table command at a switch, or you look at it from a controller's viewpoint, it just shows entries. So you actually have to spend a little time and go, well, I got to look through and see who's got the higher priorities, looking for a match, blah, blah, blah. And right now, the nice thing about it is I don't have any potential matching of flow entries with different priorities. These are all unique tests. And foundationally, we're doing things like, on a port that's controlled, I'm looking for some certain types of traffic. The BDDPs is for OpenFlow's basic link layer discovery. They actually use the same basic link layer discovery protocol with a variation theme, so that their packets will pass to find out the layer 2 environment. Who's connected to who? I gotta build a topology map. So they use BDDP packets to build that link layer discovery, or link layer environment. This next couple of tests are actually looking for DHCP, and if we get a match on these, so I'm gonna move over a little bit here. If I get a match on some of these, on these different flow entries, I'm going to have told the switch to do something. Let's say this DHCP traffic. If you get a match, go to table 200. Oh, not go out, not go up, not go over. No, we got to go look a little bit deeper. And unfortunately, I don't have the table 200 description in my screenshot. But effectively, I can tell you, go to table 200, says, send the traffic out to the normal processing and send a copy of it to the controller. So the controller has knowledge of DHCP, of what's going on, so it can build a map as well. That I just happen to know. I built another one that said if you match on basically any V4 ICMP packets, just send it out normal. You can minutely control all of the traffic in this environment. If I have traffic that doesn't match, I can have another test, kind of like what we have in ACL, the implicit deny. Okay? I can have a rule that does that. They call that the miss rule, or the miss flow definition. Basically, if I don't match anything, then I'll have a bottom one that I could drop, or I could forward, or I could do whatever I want. So what happens now on OpenFlow controlled ports is you kind of do need to think about all the different kinds of traffic. You may not need to test about everything, but you still need to make sure that traffic passes if it's not tested. So are you testing for bad? Or are you testing for unique? Or are you testing for everything? These are part of the things that we think about. Again, same kind of thinking with ACL to layer 3 plus, all right? But now putting it down at this layer 2 switch, and I can look further into the packet at the switch level to make these decisions of if I see a match, do X with it.
Excuse me, do we have first match and then go out, because we might have, say, similar match on 2, right? So
okay.
First one says.
So great questions. Can I have multiple matches? Which match will it take first? It takes it based on the first match in the table that it's in and the highest priority. So let me follow that question, my reply here a little bit. The very first, everything gets processed by the lowest numbered table. The lowest numbered table here is table 0. Table 0 says, with nothing defined as a match, match everything. And then the output function, or the action as it's called, says, go to table 100. So there is no other table 0 thing. But all traffic that comes in matches and a no match definition, right? It matches all. So it says now go to table 100. If in this case I test all these, I look for all of this types of traffic, and I didn't get a match initially, all right, for the BDP type, I don't know if that worked that far or not. I don't match BDP, I don't match my DHCPs, I didn't match ARP, I didn't match ICMP. There's another table definition here in table 100 that says match everything else. Match all. And then its function says, let me redo this. The table 100 says match output to normal. Basically says just let the switch process it as normal. I cannot jump from one table to another table until I'm told to do so. So that table 100, they call it the miss the misentry means match everything in table 0, ship it to the table 100s for further testing. Table 100 has some listings, and then effectively the last one says match anything, send it to the normal. So I could have a match in table 0's definitions, and I could have some matches in table 100, but I'd never get to the 100 unless I'm told to go there. I would only stay in the table 0s, but I have a table 0 go straight to table 100 definition.
And when I go to table 100, I follow the priority. I start with the...
I follow priorities, exactly.
Okay.
And in that case, if I was doing a, not a ping, not an R, let's just say I'm doing a SQL, all right? Then I hit this match here that says match anything else, process it as normal. Because this table 100 with a priority of 0 said it an inherent definition use of match all, go this way.
And if we have, so can we have multiple flows at the same priority?
Say it again, multiple
Can we have multiple flows in the same table with the same priority, like priority 100, table 100, and there are 2 flows?
No.
Each flow will have a different priority.
A different priority. Well, no, they could all have priority 100, but then you lose a little bit of that. So you probably want to have them at different priorities.
And who decides this priority? The controller?
Yes.
Okay.
Yeah, well, the controller / the application.
Yeah.
On the controller, or through the controller.
Okay. So we can technically then have 2 priorities, similar priorities, and then the flow matches both of them on the same table. We can technically have that, right? Let's say one says match art packet and the other one says match source MAC address.
But if they were the same person, if they were the same priority, I don't know what would happen. I don't know that you could configure it that way. I just don't know. I don't know that answer.
So technically
I
they
would
should have
not do
different
it that
priorities.
way, but, and maybe that's just the only best answer I've got. I don't think I could have 2 tests, different tests, that I could potentially match both with the same priority. I don't think it's not that you can configure it, I just don't think I would want to configure it that way. There's a possibility of 2 different tests matching, that I'd want them to be different priorities. Now, with that said, I could also say test this, test this, test this, and then if I match all 3, or match all 2, then I'm done. And so I may have to make different tests, different flow definitions to cover this kind of environment, where I do want to make sure if I do have these 2 conditions met, then I do take an action. And give that a higher priority than the 2 individual tests. So if I've got some traffic that will match these 2, I've got a unique test for that. But I have another test to match either one of these, could have the same priority, but they are lower priority, well, lower number, lower in priority function than the one that's testing both at once.
So that is when we are trying to configure the flows, we should have the most granular flows at the highest priority, so that, because lower granular will always catch them, right? Because if I match on MAC address, it will always going to catch MAC address.
No. Yeah, go ahead.
Right, and if I have IP address which is at a lower priority than that, it will never reach to it.
Just like configuring ACLs, you have to work the logic of this, okay? There's no difference from that thing. The ACLs are firewalls. Yes, sir.
So when you process a MIF, do you normally send that back to a controller, drop it, or send it? When you process a MIF, you send that back to the controller, drop it, or send it to the switch? When you MIF. When you do a MIF, or miss the definition. Like all of a sudden you've done all these flows.
Right.
And the switch receives,
Something else. Yeah.
Is the best practice to drop it, send it back to the controller, or is that just kind of personal preference?
I think that would be more personal preference. If I get traffic come in that I'm not testing for, something new,
Yeah, I mean,
what do I want to do with it? I think it depends on what I'm trying to control. If I'm thinking of kind of a security mode that I only want what I know traffic today,
then you
drop it else, right?
Okay.
If it's one of those, well, I pretty much know, but there could be something else squeaking through. I probably should allow it, otherwise that's going to elicit somebody not happy.
Yeah, because usually when you get into that situation, you get a new employee who's got an application that you don't know about, and you don't wanna just drop it, you wanna quarantine it. So, but you can get SDN to do that, right? By
Yes,
doing a
and
message.
so, and really what I would probably do in the case of traffic that I'm not specifically testing, I need to allow it because everybody still wants to work, but I want knowledge of it. I would have my miss entry say everything else, send it out normal and a copy to the controller.
Okay, with that.
So now the controller gets a copy of this packet, it doesn't have to make a decision on it, it just logs it, and I can go back and look at my log and go, what is this? And go research what's going on with that kind of traffic.
You would put that in the same table with the same priority?
Yes, I mean, yeah. I call it the table miss.
Okay.
We test everything, we need like that implicit allow,
The other, yeah.
but send it two places. Send it to normal and send it to the controller. Because I can do that, and that's how I can get that knowledge. And then I could make a further decision later, no. We don't want that traffic. Go another flow definition for a very specific new traffic type, and do something with it. Yes, sir.
So can you put multiple actions on a single flow?
Yes.
Oh, okay.
On a flow definition, I can do multiple actions.
Okay.
Becomes some of the other cool things. We don't specifically see one here, but I can say output normal and output controller. And that's what we would do in this everything else traffic that sweeps through. Look at this, we haven't got into the package yet. But this is great stuff. Yes, sir.
Would you ever want to use it to ever replace anything on the switch like DHCP snooping or anything like that?
So would I use this to replace DHCP snooping?
Or any other type of protocol?
You might. I don't know if I would yet. Okay? Because at least with like DHCP snooping, ARC spoofing, if you think about IPv6 router advertisements, snooping and all those kind of things, that's trying to tell a switch, here's the approved knowns, anything else drop. So I already have that at the switch layer. So I'm not sure I would yet, but I could effectively, but I would have to send it to like the controller, to an app to determine, is this a known or not known, and then back again. So would that cause an inordinate amount of delay? Maybe not, but you're probably gonna have to find the app to do it. But the switch has already got that. Most manageable switches have something like that, right? So, no, fair question, and these are some of the things that we can start thinking about. How do we do? Can we do? Is there an application available to do? That's part of the problem. Well, I don't mean a problem and such, but as part of this whole SDN thing is, again, I'm now doing smarter things out here at the edge, but I have to have something that knows what the smart thing to do is. So I gotta have this application, because the controller's job is to basically tell the switch, do this, a flow definition. Now, the controller may have apps that work with it, okay, but the foundation function of the controller is the communications link. So I kind of have to have something else, whether that's the human sitting there writing some code, or an application where I can go into a GUI and fill out the blank.
Okay.
Bring me the GUI. Or the other intelligent applications that they link to their, like the DNS redirection stuff. That's pretty cool. Yes, sir.
Now, from a open source perspective and having to find apps to do the things you want to do, are you opening up yourself to security risk from third-party app developers in a network management situation? Sure.
You know that answer. You asked a great question. You know the answer. If you didn't invent everything, there's risk. And since somebody says, yeah, we did our own applications. Sure they did, using somebody else's programming language, somebody else's libraries, blah, 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 blah. If you didn't invent 100% of it, there's always risk. Yes, and that is actually, they're following that whole security thinking now. What have I opened myself up to? There is some noise being made about that, and there's already a couple of SDN testing tools. You want to validate your SDN operation with a testing tool. which means you're testing by attacking, right? So there are already some tools, just like there is in the V6 world, like there's a gazillion of it in the V4 world. And there's already been a little bit of noise about, oh, we've got SDN, I've got this open environment, blah, 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 how easy is it to get in? Yes, there's risk, right? There's a few things you can do depending on the switch and the controller code. Can they, like, do some authentication? You know, okay, fine, does that still get you everything? No, right? At least you validated these two things together and somebody can't slide in the middle, perhaps, but there's going to be risk. But, you know, I don't know what else to put for that. It's something to be mindful of, and that's absolutely why you should be looking at all this stuff with Wireshark to see what really is going on, right? Who's talking to who from that environment? I'm not going to spend any time on the Wireshark thing, other than I just want to kind of point out, I'm going to use Wireshark with a configuration profile that's tuned to OpenFlow with some colors that I have tuned for certain OpenFlow packet types that I want to see, and this is kind of it. It's really obnoxious looking, and you know what? Obnoxious colors stick out. Whether you're colorblind and that doesn't look blue and red and green, it doesn't matter. Make whatever you can see obnoxious to your eyes. Does everybody know who Laura Chappell is? She's like Miss Wireshark, or Ms. Wireshark. She's Miss Protocol Decode Queen. And her basic favorite statement is, in using the coloring capability, coloring rule definitions in Wireshark, configure but ugly colors. Now, just configure some colors that will immediately stand out. When you're troubleshooting with Wireshark in a generic mode, you're trying to find the needle in the haystack that says it's their problem. Bring up things that are important to you to see with color rules, so that you see the colors fly by. Okay, I expected that. I expected that. I expected. Wait a minute, where did that one come from? All right, if a color goes flying by while you're looking at a live trace, or if you're looking at a static trace and still scrolling through it, throw the colors in there just to at least give you that very quick kind of look and feel. Here's another view of some colors. Use color rules. Use the display filters. We're going to talk about this coming up. There are 5 different OpenFlow display filter definitions, foundation definitions, in Wireshark. You want to use this one, the OpenFlow _V4. That is a display filter definition that is not for OpenFlow version 4, which is what I thought the first time. Because guess what I didn't do? I didn't read the manual on the OpenFlow display filters. I went for the OpenFlow, you're laughing at me. You know, I'm playing with OpenFlow 1.3. I went for the OpenFlow V1 definition. I got nothing. Well, I got very little. I didn't get all the new cool stuff. Oh, yeah, well, let's go read the manual on this one, Jeff, and you find out, no, the particular developer that developed a more later version chose OpenFlow _V4 to decode OpenFlow version 1.3 protocol. Yeah, they didn't ask Jeff. I happened to find out the name of the developer, and I've kind of become a pseudo friends with him. He lives in France, and I kind of sort of asked, why did you not call this OpenFlow _V or V1.3? Well, that's just not the way we do it. They didn't ask Jeff. They're not going to ask Jeff. I get this. So, like everything else in life, follow the rules. You want this display filter, by and large. It will see everything below OpenFlow version 1.3, but it is the one that you want for your decodes to see all the great things that OpenFlow version 1.3 gets you. And then there's the link. You can discover all the different display filters. Please don't get me wrong. I did not complain to the developer about that. It was just a light-hearted question of why. He told me, and that's the way it is. All right, so let's get into some packet looks right quick. I'm now running out of time. So this happens to be the trace number 2, the SDN OpenFlow Analysis -2 file that I'm looking at. I took this just under 24 hours ago. Nothing like last minute work on a presentation. Who's with me on that one? I've got, how many, 36 hours? Plenty of time. You know, thinking during, dinner and movie going, oh, you know what, I need a trace that looks a little bit different. Oh, I'll go lab that up right quick. Lab it up right quick. Who's done that one before? 90 minutes later, off of a 15-minute exercise, you've finally got it dialed in. Can you reproduce it again? That's the big question. Doing it once, and then what did I do 10 minutes ago? Okay. Anyway, so this is a newer trace file. Now, if I take out the display filter, I've got 1,933 frames. I've got a display filter shortcut, and I get it down to 601 frames. All of my OpenFlow traffic, basically. And very specifically, I wanted to see things like hello messages in color, my flow mods, my barrier requests. There's some more hellos, more flood, there's a port status, okay? And all these other packet echo requests, packet echo reply. Jeff, are you there? Jeff, are you there? Jeff, are you? I don't care about those anymore. I see a couple, I'm done, right? I'm looking for my big ticket stuff. Now, one of the other things, if you've not played with Wireshark a lot, I want to show you, if you've not noticed, in the 2.0 family, they added another scroll. Initially, they integrated the coloring into the scroll bar in the early versions of 2. Finally, they took it out and moved the color indicator next to the scroll bar. So this tells me, in this much of the trace, I've got some of these different colors there. It's a quick navigation. I can go click over there on that color sidebar and get to those packets quicker. Okay? If you're not working in Wireshark 2.1 and above, and 2.2 is the more recent, don't blink, don't think, upgrade. Just do it. Okay? If you're a Mac user, you will certainly love it if you've ever installed old Wireshark, because in the older Wireshark before 2.0, you had to install X11, X10 and then X11. All right? Now, they've retooled it all. It's the same Wireshark GUI across Windows, Mac, and Linux. So now, when you switched in the old days between a Mac and a Windows computer, things were in different places in Wireshark. Now everything is the same place. Now it all works the same. That was one of the bigger, monster, heavily lauded features of the 2X family. So again, a large part of what I'm trying to do with this kind of definition, or this kind of look and feel here, is I want to find some of these packets. I want to find them quick. So I built the color wheel definitions. As a very quick thing, I've got a flow mod. I expect fairly quickly behind who sends the flow mod? Controller or switch? Controller? Or switch?
Controller.
All right. Say controller twice. Must be good. Don't change the answer. Always go with first. All right? Controller sends the flow mod. Who sends the barrier request?
Controller.
Are you sure?
Yeah.
Absolutely?
Yeah.
Really?
Yeah. There's acknowledgement for the barrier, but...
You're right. I'm just making sure. Who sends the barrier reply?
Switch.
Are you sure?
Yeah.
All right. I would like a color for the barrier reply message. I don't have one currently. It's mingled in there with all those hello, are you there packets. Right click on, well, first off, sit down where I can do this. Select the barrier reply, right click on that portion of the packet, go to colorize with filter, say new coloring rule, say barrier reply, pick an interesting color for it, say okay, and then I got yellow packets. And now, I could go through here and quick, oh, did you see a yellow go by?
Yeah.
More yellow? All right, this is how colors help you. I see 3 packets in this view But yet, even looking at the packet numbers, 779, 835, 836, okay, they're all close enough in succession. And if I really went to the detail of looking at who's talking to who, I can see that 31 is the sender, that's obviously the controller, 246 is the switch in this case, and they're all in quick succession. And now I can just go, okay, blah, blah, yep, there went a 3, yeah, there went some more, all right, oh, look, a flow removed. I might want to say, ooh, another interesting packet type, let's go build a color for that real quick. Color, new coloring rule,
Magenta.
or kill. Flow removed. And let's give it a color, and let's give it, this light blue.
Where is the data IP?
This is where colors can help. I'm looking for packet types, looking through quickly, and this is not a big trace. Most of the time, we're not luxury of dealing with a small 1900 packet trace, right? That barely is anything in the real world. That's like, oh, you turned it on for a split second. No. We're going to be looking at that half a gig or half a terabyte trace file, right? So, anyway, we can see how colors can help.
Just where is the idea?
Hellos occur. These are some things. Hang on half a sec.
Oh.
No, go ahead. I'll show this.
ID of the switch. What's that called? Data ID? Data path ID?
Say again?
Data path ID.
The DPID, where is it?
Just say it again. Say you have to say it.
Oh, I don't. DPID.
DPID. Data path identifier. And it comes, where is it in there? Really? Really? You want to see the DPID? All right. We'll look at that. I clicked on the flow mod packet, and we'll see. The interesting thing is we don't see the DPID in all of these. Oh, actually, you know what? I have an idea where we'll see it. In the feature reply. Okay? So here's another great example. I would like to build a display filter on DPIDs. Before I play with color filters and how quick those are, right? Go find a piece of the packet, build a color on that piece of the packet, any matches to that component in a packet gets a color. Now I want to build a display filter on data path ID. So I highlight that section, I do a prepare as a filter, I'm going to say selected, and then click on the blue right facing arrow and say DPID. Now, I am probably going to want to look at DPIDs again someday. All right? So, that particular DPID, I can click, well, we can't see all this very well. Let me blow this up a little. So, it built that display filter for that DPID. Okay? If I want to save that, I go over here to the plus, and this is effectively going to give me the capability of creating a name for this display filter, and we'll say DPID, pardon me, for switch 1. I need to make this a little bit smaller. And then go over here and say OK, and then look at all of my display filters, and there's the DPID for switch 1. So I can, these are all the display filters I have configured right now. So let's just, where I was kind of headed, I want to look at just hello packets. And I can fundamentally see, out of all these hello packets, a couple of different switches. Remember that 31, or to remember, 31 is the controller. So 246 talk to the controller, and .55 talk to the controller. You might have remembered that from that show output of the controller itself, where I had the switches listed. Now, another interesting filter type, let me minimize this, that I have defined over here, is I wanted to uniquely see the manufacturer description within the OpenFlow package. Because right now, all I know is a couple of things talk to the controller by IP address. What brand of switches are those? So I've got a different display filter, and I can go down into the packet. Let me get out of this Zoom. And now I can see 246 is the Aruba switch. You can't see.
And there seem to be TCP packets.
The 51, hang on a second, excuse me, the 55 is the Nicira. What question?
There seem to be TCP packets instead of UDP. OpenFlow packets, they're running over TCP.
Oh, yes. Yes. Well, I said UDP, didn't I?
Yeah.
It is TCP. Ooh, good catch. It is TCP 6633 or 6650. TCP, not UDP. Don't listen to Jeff earlier. Jeff later.
That's just the transfer.
That was a test. He passed. Isn't that how good presenters get past their mistakes?
Somewhere without Wireshark. When we still needed the barrier message?
Well, there will be barrier messages after flow mods.
Yeah, because if flow mod is there, then it would get acknowledged because it was a TCP, but then why would...
Well, you don't get any knowledge of what the switch actually did. The barrier says, what did you do? The switch says, here's what I did. Not that I just got your packet. Yeah, that's a generic TCP, but now I want to know more at the application layer with the barrier request reply. Switch, what did you really do? This is what I built. There's the flow definition that I built. So, let me just kind of go back to these OpenFlow, all the OpenFlow packets. And so, again, a little harder to see because I need to zoom in. I've got all kinds of OpenFlow display filters that I had already created. I created them as easy as we just did looking at that one DPID. Okay, you go into the packet, you find what's the interesting bit of information, and then right-click and you can build colors, you can build display filters, and you'll play with this more and more over time, or I would recommend you do. How many use Wireshark just out of the box? Don't be shy, because you're probably not in it that often, right? You hate to get into Wireshark because that means something's really, really bad, and they're blaming you for it. You just open it, miraculously, Wireshark will tell you the problem. And by and large, Wireshark can do a lot of things. There's a lot of smarts in Wireshark, right? It's not just a packet deco. There you go. I'll decode the package for you. Next. There's a lot of extra stuff in there, but we still have to kind of apply us at Google into the formula, right? To be able to go, I found a packet of interest. Server guys, found the packet of interest. Now, my other favorite feature along with that thinking, and I'm just going to right-click on a packet, is that you can do packet annotation. You can embed metadata about a packet. This is great for when you need to share the packet with the other team members that really need to go fix their problem. Typically, you fire up an email, you're thinking to yourself, I found the problem. It's in packets, blah, 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 blah. Here's what it looks like, here's what I think it is, and here's the trace file with an attachment. Done. That's the done key you just pressed, right? Done. Check off, ticket closed by me, or my portion of it anyway, right? Next. Well, that's all fine and good, but wouldn't it be great when you see the packet right then and there to be able to make a comment in Wireshark, right-click, go to packet comment, and say, server team, found your problem here. All right? And then you send them the trace. And along with that, you're going to be a really, really nice person saying, open up that trace with Wireshark, go to the display filter area, type PKT_comment, hit the enter key, and this will bring up the packet or packets that have data in there that you need to go look at. And when you get to that packet or package, open up the packets comment field, and I have provided you what I think is the info you need, parentheses, to fix your problem. And maybe I'll do that, because we don't have to be very political, we love our jobs, right? We're not gonna lose our job over being, well, I try not to lose my job over being stupid. Anyway, packet comments are metadata, they're staying in the packet. When you save it again, okay, you do a save, and it's in the email, I believe I found the problem, do this, and then you've given them everything they need. You might even send them a link to Wireshark to download, because you expect the server team to be looking at packets? Yes, if they're a Microsoft world, they'll be using the Microsoft Message Analyzer decoder, but it'll read PCAP files as well, okay? Anyway, making packet comments FSEC is a very good thing to do in a couple of idea processes. One, you're in a lab. You're verifying things work. As you see things that work, go make a comment. This was a good communication of the switch to the controller. This was a good this. This was a good that. When you then go do your implementation, you do the same thing. In the production, this was a good here, this is a good here, this is a good here. Because how in the world are you going to know 6 months later from now what's good and what's not good? All right? It'd be nice if you had these traces. So you got all these comments, you got your split.
What are some common problems you see with OpenFlow that show up in traces quite often? Like with some certain things like delayed ACK, we look for like delayed ACK or, something that could indicate a storage problem or server problem, something like that, or this IO bound, memory bound.
Well, I guess from my own personal experience, I've not found a lot. So we're troubleshooting, perhaps in the SDN environment, what's the issue? More of the issue comes from typos in configuration. You sit there, you configure a switch. Please tell me everybody has done this once, and I'm not the only person. You configured it, it's not working. And you've looked at it, and you've looked at it. You've gone to sleep and looked at it again. You've had somebody over your shoulder. You've had somebody in the chair. They killed the command line and they retyped it. And we all made the same mistake. I typically more find that. Like my problem where my switch was speaking on 6633, the controller is on 6653. And I'm sitting there looking, going, well, the switch said hello. And the controller goes, I don't know anything about that. Cost it. Well, that was easy. Server guy, but that was me, right? I got to read the books. So it's more typical of things of either misconfiguration and initial things don't work, to a potential that an SDN app or the controller with an app on it might not understand what the capabilities of a switch might be. Because, as I say, the switches could support OpenFlow 1.3, but not support multiple tables. This is actually a real semi-common, okay? It's older switch technology. And just because it's well, I would show up with an error message back from the switch, basically through that barrier, the barrier reply. The controller said, switch, do this.
I saw an OpenFlow error in there when you were
and I did look at that, and that's, there could be some in there. So it's more of that either initial or communications because of their not understanding, or the capabilities of the switches maybe. So right there it is, OpenFlow error. So we look at this, and we're saying that this was sent, the controller sent something to this .55 switch, and the switch basically came back and said, it looks like you tried to send me a multi-part request. I can't do that. Well, that 55 switch is the MiniNet switch emulator. So the OpenFlow controller, or the application that was being used to define the flow definition, may have sent it, and that switch, in this case, MiniNet's like, no, I can't do that. So, a potential error. So, with that in mind, let's take the error, let's make another little color for that. Colorize, a new coloring rule, OpenFlow error, and give this a color, and let's pick something, what do we have?
Pink.
Something.
Orange.
Oh,
Aren't you glad I chose that?
and the other thing I might wanna do with that is, go back to that, build a display filter for errors. I'm selected, and I'm going to just save that real quickly, call it OpenFlow error, and okay, and we see that out of that, 600 some OpenFlow packets, 3 of them were errors, 2 from the MiniNet, and 1 from the Aruba switch. And we look at this and it says, the config failed. It looks like you tried to do some sort of a configuration set, and that's not possible on the switch. So the flow mod was to, or the configuration mod was to say, I controller want you switch to configure a little differently than your traditional config, and the switch said, can't do that.
And then we can use the transaction ID to,
Go ahead.
sorry, and we can use the transaction ID to identify what that flow message was, for which we errored out, right?
Say that again?
Then we can use so this is the error that I was not able to configure something.
Right.
But then I can use the transaction ID in the error to identify what really was being sent by the
Well, sure,
controller.
yeah, exactly. Work it backwards. Absolutely, try to find out what it was that was sent and why the switch didn't like it.
Yeah, I was hoping I would hear the answer, but, I'm trying to find out, does that error happen often? Does that error come about often where it would cause a problem?
In 600 OpenFlow packets, we only had 3.
Right.
I don't consider that often.
I know that, but, you know.
But I might consider this, I need to go research it to find out what I was trying to do, so that I can I do something different, or I just can't do that.
And you'd wanna put your sniffer in this particular instance on the controller, network, right? If they were on different networks.
Well, you could put your put your packet capture utility potentially on the controller. Now, in this particular case, this controller and most of the ones I've played with so far are based on Linux. So I could use T-Sharp, right, or some other capturing capability. In my particular case, in this particular environment, it was all virtual, and I just put a Windows 7 computer on that same virtual interface, and so I saw all the traffic. In my physical lab, I put a packet capture on the same network, and I can see it, or I'll span mirror the controller port, physical port. So a couple different ways, but yeah, basically I need to see everything in and out of the controller. However, whatever state I can get to. In that other trace, and I'm almost out of time, in that other trace there are 2 switches. One is on the same network, same 192 network as the controller, and the other one is off of a routed link. And so you'll actually see that represented by the .1 router number as looking like, at the trace level, the IP address, but you'll actually see the correct one if you have the controller GUI. You see it. So these traces, these 2 trace files are the number 1 or the first one that I didn't show is just a little bit bigger trace file, has a little bit more OpenFlow, but not a lot. This particular trace, the one I got last night, this number 2, is a very succinct. So I started Wireshark, and then I told the switches, go talk to a controller. So I got my hellos, and I got my configuration information, and then the controller, by default, sends out a few flow mod definitions for looking at, give me a copy of DHCP, look at the ARM, and something else. And then I actually used another application with the controller to do that ICMP config. And so there's another flow mod. So as you're looking at these things with Wireshark out of the box, you're going to see all one color. You're not going to see colors, right? You would have to build the color rules. You would have to look at these different kinds of packets. But if you start with the initial OpenFlow display filter up there, and so I'll show that again, right? OpenFlow underscore v4. So if I were to take that out and just look at all my packets, then I would, hello? then we can kind of see here all these other packets that aren't just OpenFlow, right? There's 1900 change. I put in that display filter, and then I trim it down. Then you can go and look at the different types of packets over here and say, well, I want to look at this, or I want to look at that. We see the hello, and up here. We see the features reply message. We see some errors. We see some multi-part information. Lots of different things here. See the 246. As we keep going down, we see 31, 246, where there's 55. There was a hello message up in there somewhere. There it is. So I see a second switch come online, the MiniNet switch. All right. So you can play with these files. There's nothing secret about these files. They're, once you get them on box.com, they're out there. That's the way it goes. So
Nobody's making any kind of, display filters that we can import for different types of things we're trying to do.
I started to take my little OpenFlow definition. The problem is it had other stuff in there. It wasn't clean yet. So I'll try to do that. Maybe just get a fresh Wireshark. It has like recent files going on. There's a guy locally with Windstream, I can't remember. He's been collecting display filter definitions. But I can't remember who it is. Cellstream. That's it. The Cellstream. If you go to CELLstream, I think, .com, or just Google on Cellstream and Wireshark, and you might find, again, he's local. He tweeted out something within the last about 3 weeks that he had putting together basically a place to collect display filter definitions. And I had been thinking about this for OpenFlow that I should create a clean one and pop it up.
Great.
But yes, that is the nice thing about the display filters, the color rules, all this information, even your configuration profile, it's all portable information. So once you build one for yourself, you can share it amongst your team, or put it open, for the outside world, whatever, for others to use. So that was really quick. I know probably a lot more time in the early stages. I think it makes more sense when you kind of get to the trace off. Was this at least interesting, if nothing else? Give you maybe a little bit more thinking of using Wireshark. Wireshark should be your friend if you're a network person, okay? It should be your friend from the aspect of learn a little bit more of its use. Just tinker with it. Play with the color rules. Play with the display filters a little bit, because it is so powerful in helping you maneuver through that haystack, trying to find the packet. Because you're just hoping that packet miraculously springs to the top of the pile. You go, here we are. And it's not. By and large, it's not. You're going to have to wade through and get rid of a lot of the stuff. And display filters can help you do that. Coloring, you can sit there and go, okay, all these kinds of packets I don't need to know about. So you can build a display filter by selecting each one and say, not this one, not this one, not this one, not this one. And just keep leading down the number of packets to look at. Or drill down drill down to a protocol level or to an application right off the bat and, not be looking at all that other stuff, all that other traffic that's going on. So SDN is one. I've done IPv6 a couple times. And these are the kind of things I like to talk about. So, question?
Yeah. So, a couple of years back, SDN was really in hype, means that all the world is going towards SDN. But now we see a lot of overlay networks, VXLAN, and ACI, they all are coming in, right? So after that, how's the adoption curve of SDN going on? Is it still going on steeply, or is it stabilized?
It appears to be that SDN is increasing. There's more noise on a fairly daily basis about entities. There was literally just something in the last couple of days, and it was like a Google or a Facebook talking about things they're doing with SDN at the network level. In addition to some of these other way cool things both of those companies do. There's a big amount of noise on SD-WAN that the telco providers are kind of talking about, where they're doing a similar type function, but for the WAN side of the technology. And that's all I know about it. Just enough to barely say that I've heard it.
Do you know any
but there's more people that are showing interest. There's more exploratory. Well, what can SDN do for me? Because we're hearing these bits and pieces of things. There's all kinds of news articles. There's lots of little noise in the Open Network Foundation and the open kind of source networking environment about this SDN thing. And the manufacturers are doing a little bit more to it. I'll give a plug to HPE, not because I work for them, but because of what they do. They were one of the first manufacturers working with SDN when a group at Stanford started this as a project. And they invited HPE and a couple other companies in as well. And one of the things that HPE saw kind of off the bat is, if a controller is the controller, but I need these applications, who's going to do the applications? Who's going to do that work? And so they started, at least the first group to start, to openly invite entities to write applications. They made a big API set available. And they started an SDN app store. So you can actually go get applications from HP, not Firefox, the F5, Blue Cat, a load balancing entity, a couple security entities, actually a couple of DNS entities, where they have written these applications to work with their application in the network, for like DNS redirects, for like load balancing technology. And so they kind of opened it up and invited that. The only other real work that's been done there has been with the Open Data Controller, the ODL. And there's a few of those same entities that have written their apps also to the Open Daylight. And actually, HPE has those on their app store as well, because they're kind of part of this open support thing. So there's a lot of other potential controllers available, but not a lot of other apps for them unless that manufacturer is written. And there's some of that going on. So it's one of those things, yeah, there's different controllers that you can get, but what else goes with it is helpful. There's switching technology that would support it, but does it support all the features you want, right? So there's a little bit of a list of work that you kind of want to do, and that's an exploratory bit, you know? Because we all have at least an extra 5 minutes this year to spend on a project that's not funded or not part of the, you know, the master plan, right? You can do a lot in 5 minutes. Truly, and being sarcastic, yes, but, you know, you can at least play with SDN in a light-duty world with these open source controllers, with the MiniNet emulator, on your own box, with VirtualBox or, you know, some other virtualization technology, and play and learn with it in this mode. You've got some traces, you can do some things, make it look similar, and play, you know, play with it and see what it does.
And have you seen production implementation of these?
Say again?
Have you seen production implementation of
I cannot say I myself have, but I have heard.
There are production.
Okay, and there's tons of information out there from basically all the manufacturers of their customer projects. There's lots of white paper information for people doing it. I just can't say that I have. I don't get out to get to the real world as much as I used to. That's just the nature of my job at the moment. I get to hear cool stories, and I play. I do a lot of playing. I want to know. And some of it's part of my job. You know, I don't necessarily have to do all this kind of stuff, I would say, in my training job, but we do some of these things in our labs, and I play with this, and I was showing my class today this trace, because I had all these cool colors, and I said, your lab at looking at these things is going to all look plain vanilla. Here's what colors can do for you, and I just, you know, show a quick little screenshot. So, you know, that's a little bit of extra. Anything else? This is worth your time tonight to at least kind of come and see something different. Let the user group leadership know things you want to hear and see in the future, and they'll do their best to get somebody. And if you've got a great idea of something to talk about, they always will say, yeah, come on up, right? You don't have to be an expert in it. I will never claim to be an expert, right? Because if I don't know, I'm just going to Google it. Somebody else will know.
Absolutely awesome. Great. Okay, well, so we have our book raffle, and, well, as we said earlier,